currently pursuing BE in Electronics and Communication in Sri Venkateswara College of Engineering. I am from 3rd semester A section, Department Electronics and Communication. Today my subject is Mathematics for Triple E stream and the topic is how to represent signals in Fourier transform. Representing signals in a Fourier transform typically involves expressing the signal in both the time domain and the frequency domain and explaining the transformation between them. Let us see about the introduction to Fourier transform. Briefly explain what Fourier transform is. A mathematical tool to analyze signals in the frequency domain. Decomposes a time domain signal into its sinusoidal components. Time domain. Representation describes the signals in the time domain. For example, a waveform like a sine wave, square wave, etc. Provide a mathematical equation for the signal. For example, x of t is equals to a sine of 2 pi f of t plus pi, where a is amplitude, f of 0 is frequency and pi is phase. Plot the time domain signal for better visualization. Frequency domain. Define how the Fourier transforms the signal. Continuous time Fourier transform CTFT f of xf of t is equals to int of infinity to the power infinity x of t e to the power minus j2 pi f of t into dt, where x of f is the frequency spectrum of the signal. Explain that x of f shows the amplitude and phase of different frequency components. Decomposition of signals. Using Fourier transform, any signal can be decomposed into amplitude spectrum and phase spectrum. Amplitude spectrum, x of f shows the strength of each frequency component. Phase spectrum, text x of f shows the phase shift of each frequency component. Let us see about the graphical representation in Fourier transform. Time domain, plot x of t or x of n as a function of time. Frequency domain, plot x of mod x of f and text x of f against frequency of f. Fourier transform pair. The relationship between the time and frequency domain is bidirectional. Forward transform and inverse transform. In forward transform, x of t to x of f. In inverse transform, x of f to x of t. Let us see about the examples. Example 1. Signal frequency signal. Time domain, x of t is equals to sine 2 pi f of t. Frequency domain, a single peak at f. Example 2. Square wave. Time domain, repetitive waveform. Frequency domain, infinite harmonics at odd multiples of the fundamental frequency. Common signals and their Fourier transforms. Provide examples of standard signals and their Fourier transforms. Sine wave, a delta function at Pm f of 0. Sine wave, combination like spectrum with odd harmonics. Impulse, flat spectrum across all frequencies. Plots and visualization include time domain plot, signal as a function of time. Frequency domain plot, magnitude and phase spectrum. Label the axis. Time domain, time t versus amplitude x of t. Frequency domain, frequency f versus amplitude mod x of f. Let us see about the properties of Fourier transform. Transform linearity. Second point, duality time and frequency. And the last point, scaling convolution theorem. Applications of Fourier transform. Explain practical applications, signal processing, audio analysis, image compression, communication systems. Thank you for watching.